then is x into x plus 2 plus x plus 2 whole square by 2 minus, when I put the lower limit, then x into x, which is equal to x square plus x square by 2. Okay, this is the limit. Okay, so after all calculation of this x, we can find the expression of x, and then we will integrate this with respect to x. And after the calculating all these things, we will get that all the solution of calculation of this one, we will get 0 to 2, this all equal to 4x plus 2. We can easily calculate this one. Okay, so this is equal to 0 to 2, 4x plus 2 dx. Okay, and then we will integrate, so we will get is equal to we will get 4x square by 2 plus 2x, and the limit is from 0 to 2. Okay, so which is equal to, by the calculation, this is 2x square plus 2x, and by the putting the limit, I will get, if we put here 2, then 2 square 4 into 2 is equal to 8 plus 2 into 2 is equal to 4. And when we put the lower limit is 0, so this all will equal to 0, and the answer is 12. So this is the another example which was asked in the exam of January 2009 GTU. Okay, so these are most important example okay, related to which this method is very important. Okay, look at the PPT, then we can see that there are some more example of this is one more example of integration. So here the limit of x is 0 to 2, and limit of y is x squared to 2x, and the diagram, from the diagram we can see the region D in the shaded area. Okay, so this is the integration of x square plus y square 0 to 2 and x squared to 2x. So after the calculation, first with respect to integration with respect to y, and putting the limit of y, then we will get the equation of expression in x, and then integration with respect to x we will get, and the answer 216 upon 35. Okay, this is the expression. Okay, also we can put here in the previous this example, first we have put the limit of x, we have fixed the limit of x, that is 0 from 2, and y, limit of y is x squared from 2x. If we fix the limit of y first and then express x in the terms of y, then also reason will be the same, and we can solve this example in the another way. This is called the change the order of integration. We can change the order of integration in this example, putting first fix the value limit of y, and then express x in the values of y. So in this slide we can see that if we fix the limit of y, then the 0 lesser or equal to y lesser or equal to 4, and if we express x in the terms of y, then 1 of 2 into y, which is lesser or equal to x lesser or equal to root y. That means the limit of x is from y by 1 by 2y to root y. And this way also we can integrate the example, and we can see here that after the putting the limit of x from y by 2 to root y, and the limit of y is from 0 to 4, and integration in this way, we will get the answer the same is 216 by 35. So this is the main thing to remember, that if we change the order of integration, then the answer will not be changed. So we can go in the either way. If we want to fix the x and express y in term of x, otherwise we can fix the y and then express x in terms of y. In both way the answer will be same. Okay, this is the next example to evaluate xy, where the region is bounded by y is equal to x minus 1 and the parabola y square is equal to 2x plus 6. So we can see the diagram here, and from the diagram, if we fix the limit, then limit of y is minus 2 to 4, and the limit of x is also expressed in the terms of y. So by the integration we will get minus 2 to 4, y square by 2 minus 3 2 y plus 1 xy dx dy. So here, after all the calculation and the integration, we will get the evaluation of this example is 36. So this is the now we quickly move to the next section, which is the change of variable in multiple integral. So in the change of variables example, there are so many kind of example normally asked, but the polar coordinates is very important in the change of variable type example. So we will concentrate more on the change of variable from Cartesian coordinates to polar coordinates. Let us first discuss about some basics. The new variable, if we take r and theta, are related to the old variables, which is our normal variables x and y. If we take the polar coordinate, we all know that polar coordinates are x is equal to r cos theta and y is equal to r sin theta. But when we change the coordinates, x is equal to r cos theta and y is equal to r sin theta, then there are some changes in the integral is well. So this is then our integration will be f of xy dA will be f of r cos theta, r sin theta, and r. Here r is the Jacobian with respect to this transformation from xy to r theta. Okay, we can also change a variable from xy to uv. So let us see how a change of variable affects a double integration. So here x is equal to r cos theta and y is equal to r sin theta. So here the Jacobian of transformation, because we have changing the transformation from xy to r and theta. So here the Jacobian is del xy by del r theta, which is in the determinant form del x by del r, del x by del theta, del y by del r, del x by del y by del theta. Sorry, there is the print mistake, del y by del theta. So del x by del r is equal to cos theta, then minus r sin theta, then sin theta r cos theta. So this will be r. So as I discussed, then the Jacobian for the change of variable from Cartesian coordinates to polar coordinates, the value of Jacobian will be r, and r is greater than 0. So after all this calculation, we will get if f of xy dx dy will be changed into f of r cos theta, r sin theta, Jacobian del xy by del uv, del r theta. So after all, we will get the expression f of r theta, where the Jacobian is r dr d theta. So let us look at one more example manually first for the change of variable. Let us look at one more example. The question is evaluate zero to a 0 to in root a square minus y square in root x square plus y square, okay, dy dx. This example was asked in GTU, okay. So here if we take the polar coordinates, x is equal to r cos theta and y is equal to r sin theta. To first fix the limit of then Jacobian j is equal to r as we have discussed, okay, and then we need to find the limit of r and theta as well. So if we draw the diagram first, so we will get easily, okay, the limit of x is from 0 to, limit of y is from 0 to a, so it's from here to here. And if we look at the diagram here, 0 less than or equal to y less than or equal to a, and 0 less than or equal to x less than or equal to in root a square minus y square, okay. So from this one we will get x square plus y square is equal to a square, which is the circle with the center 0 0 and radius a. So this diagram will be like this. This is the center 0 0 and radius a, and the limit of y is from 0 to a. So here y is equal to 0, that means x axis, and this is the y is equal to a. So this is y is equal to a line. So here x is also greater or equal to 0 and y is greater or equal to 0. So after all, our area of region is this one, which will be in the first quadrant. So this is 0 0, this is a 0, this is 0a, okay. So from here we can say that this is the radius of this circle is a. So limit of r is 0 less than or equal to r less than or equal to a, and this is the only first quadrant. So angle theta is bounded between 0 to pi by 2, because here theta is equal to 0 and here theta is equal to pi by 2. So limit of theta is equal to 0 from pi by 2. So now we are ready to evaluate this example. So our example will be changed into limit of r is equal to 0 to a, limit of theta which is 0 from pi by 2, and in the question there is a y square, so y is equal to r sin theta, so r square sin square theta, then in root x square plus y square, so in root x square plus y square, that means r square cos square theta plus r square sin square theta. Then there is a Jacobian j, and then d theta dr, okay. So after simplifying this one, we will get 0 to a, 0 to pi by 2, this is r square sin square theta, and this one r square cos square theta plus sin square theta is equal to 1, so this is r square in root, that is equal to r, and Jacobian is also equal to r into d theta dr. So after all, we will get 0 to a, 0 to pi by 2, r raised to 4 sin square theta d theta dr, okay. So here first we will evaluate with respect to, we will integrate with respect to theta first, then we will integrate with respect to r. So here is equal to 0 to a r raised to 4 0 to pi by 2 sine square theta d theta dr. Okay, so after the if we want to evaluate this one, then we have to use the trigonometry function. We know that sine square theta is equal to 1 minus cos 2 theta divided by 2. So we will put here, instead of sine square theta, 1 minus cos 2 theta divided by 2. Okay, and then if we integrate with respect to theta, we will get here this is 1 minus cos 2 theta divided by 2. Okay, so from here one by 2 is constant, so I put it here. Here the integration will be theta minus sine 2 theta divided by 2, 0 from pi by 2. Okay, dr. So this is equal to 1 by 2 from 0 to a r raised to 4 here pi by 2. This is the upper limit. Here when I put the pi by 2, then 2 into pi by 2, that means sine pi is equal to 0, so this will equal to 0. And then when I put the lower limit 0, then theta is equal to 0 and sine 0 is equal to 0. So here just let only pi by 2 dr. So after all we will get is equal to pi by 4 0 to a r raised to 4 dr. And after evaluating this one, we will get is equal to pi by 4 integration of r raised to 4 is equal to r raised to 5 by 5 at